Good evening, everyone, and thank you for joining us tonight. My project is titled Municipal Solid Waste Management, Integrated Alley Centerline Network Designed for Routing Optimization. Now, as John mentioned, this is an ongoing project that I've been doing as an intern for the City of Tucson Environmental Services. Environmental Services, of course, it manages the waste collection for the City of Tucson. And for tonight's agenda, topics I'll be going over, I'll start off with my introduction. I'll go over my background studies, discuss my study area, go over my data sources, methods, followed by results, and end with the conclusion. All right, so this project takes place obviously in Tucson, Arizona, which is located in Pima County. It's 108 miles southeast of Phoenix, Arizona, 60 miles north of the US-Mexico border. Has a population of 527,927 as of 2014 US Census population. It covers 236.5 square miles. And here's a map just to show Tucson. Okay, center lines. Well, center lines are a framework layer that have the ability to support address matching, transportation modeling, roadway management, and vehicle routing. Now, for environmental services, they are an enterprise fund, which, here's by definition, establishes an enterprise fund establishes a separate account for municipal services to charge a fee in exchange for goods or services. So basically, the fees they collect from the service they provide goes back into their account as what keeps them in operation. They provide residential service 5 days a week to 140,000 residents. So the way this project first started out, environmental services is looking at purchasing automated routing software to modify their existing waste collection routes. Well, these routes also include alley routes. Alley-based service accounts for 25 to 30% of residential waste collection. Now, alleys are not part of the street network. They're not named. So for automated routing to occur, you'll be using the street network, but you can't route through alleys. So this is where the creation of an alley network comes into place. But in order for this to happen, the alley network needs to have the same data, needs to have the same attribute data structure and function just as the street network would. So the end result of the project would be to create an alley centerline network, combine that with the street network. When you have those combined, you have a fully operational transportation model that you can use for this automated routing software. So GIS and waste management. Prior studies done by Karadimas 2007 and Tavares 2008 both used GIS to optimize their existing waste collection routes. The results they came up with was that they were able to enhance efficiency of their collection routes, minimize the travel distance, and reduce the costs associated with vehicle maintenance, labor, and fuel consumption. Moving on to my study area. Now, of course, my study area focuses in Tucson. Here is all the alleys that environmental services. As far as alley segments, you're looking at about 4,100 segments right now. Not alleyways, but segments. Now, the 5 days of service for our environmental service are based on by day Monday, Tuesday, Wednesday, Thursday, Friday. As you can see, these areas exist mainly around downtown, west, nothing too much south. Now, I'm going to show you my study areas right now, but these will come into play later on into the presentation. But I had two study areas, Area 1, which is north of downtown, west of the University of Arizona, so just right down the street, and the other one is just south of downtown, located near the Thomas Price Building where environmental services is located. To show you a closer view, here's study area 1, which contains 101 alley segments. Total length of these segments is 5.9 miles. Study area 2 has 195 alley segments for a total length of 23.4 miles. So my data, sources where I obtained my data from was City of Tucson, Pima County GIS, and my data was collected using the collector application from ArcGIS. My coordinate systems and my projection. My methods. Well, to begin, I had to go through a network construction. This meant building the parameters, establishing parameters that would be incorporated into this alley network. Well, those parameters would have to include the street network as well as those from the routing software. But again, alleys we had to come up with a naming convention because alleys don't have a name. Next part was the physical development, which was to start building the infrastructure using the existing alley layers that the environmental service had. Using that layer, I had to take in consideration and start using the audit field map, the field audit maps, which had updates from drivers who were basically doing the routes and explaining or telling me which alley segments were there or which ones were not along the route. Through that, I started digitizing with the parameters in place. Once those were digitized, I had to go ahead and make sure I had a coincident geometry by running topology on the network after I did my merger and integration. For the web map creation, this came in place afterwards, which had to build a geodatabase, use my data, which was the containers and the alley segments, place those within the geodatabase, set my coded values, published the map, and launched it on ArcGIS online, and then went through with my collector application to collect the data. The reason for this creation of this web map was because it was in order to show the City of Tucson that in lieu of the paper field audit maps, this would be an alternative way to go out and collect data and maintain a current inventory of their containers as well as alley segments. The results. Well, we had to come up with a naming convention. Unfortunately, my boss said I couldn't name each alley, so there was another conventional way, which was for any alley with an east to west orientation, it would take the name of the south street. If it had north to south orientation, it would take the name of the west street. Now, they would also be assigned a block range based on the street segment. They would begin a street type of alley, in this case, well, short abbreviation would be AL, and they would be given an alley ID. Showing an example, here would be the naming convention. In orange, you have an alley segment running south to north. To the west is Country Club. Well, the address range would be the minimum of 3,000 to 399, 3,000, 3,099. But the address ranges are flipped because normally on your right side you have your even address ranges, and on your left you have your odd address ranges. Well, in this case, your left are even and your right are odd. So this was done for every segment going through digitizing. They had to be reversed and separated wherever there was a directional split or another segment added. So it was given a prefix of north, street name of Country Club. The alley ID is based on the intersecting block, which if it's a north to south segment, it would take the north block first, followed by the second 100 block. So 03,000 north, 03100 east. Now what you see here is a subdivision plat map, which I use to go through and validate the existence and location of each alley and determine the width. So as you can see, there's, well, maybe about, 15 parcels here. Actually more than that, but for each parcel, there's an alley segment. And in order to maximize my flow of productivity for each alley segment, I needed to know the subdivision map and page number for each one. Well, if you look at all these, so I created a geoprocessing tool which would eventually create another feature class by dissolving all the subplats, all the parcels into one, all the parcels that had the same subdivision map and page number will be dissolved into one. So I'll show you the example. So here you have all your parcels based on street number. You have hundreds right here. After my new creation of the field or the feature class, it combined all those. Now I have all my subdivisions combined into one, so I could go ahead and pick all my alley segments within one subdivision, which allows me to go from subdivision to subdivision, digitizing and working in each alley segment. So as I was working through the process, not only using subplat division maps, but also 2014 orthophoto imagery to digitize one. So using the existing alley segment, problems that I encounter is, as you can see, you have the top alley, which is curving to the left, crossing parcel boundaries. There's a fence line there. I have to go through and verify it. The plat map is running north to south. It doesn't curve left. So I have to just go in, fix it, get it going, and start adding my attribute my attributes. So attribute development. This is what, if you were to click on one alley segment on the old layer, you would bring up about 12 attribute fields. Not a whole lot there. But now, with the new alley attributes, you have about 42, all containing, you have your alley ID, the book and page number, a link which you can click on that will take you straight to the subdivision map and page number. So if you need to verify, is this alley real or what, you can go ahead and verify through there. It has a Tucson city code for the speed limits, which is 15. Has the department usage, the travel direction for alleys. There's both ways of travel. There's only 16 alleys in the city of Tucson that are designated as one way. You have your functional classification code, your address ranges, last action date, your number of lanes, your road passability, and so forth. Now, once all this is done, I have to get my networks together. So using the merge tool, take my alley layer and the street network, merged them together, brought those into a feature database with a feature data set, build my topology, and as a rule, I set it to must not have dangles. And after running topology, I had to do some error or some editing because what I found out was the cluster tolerance, the existing alleys had a cluster tolerance of 5 that were short. So I had to adjust the cluster tolerance and snap everything together. So what you have here is just a snapshot of the alley network in place as is. Here's a street network, and after running my topology and merging everything, now you can see it doubled into the alley street network, which is all integrated, fully connected. Now, as far as the web map creation, like I said, this was an additional tool for the city of Tucson to maintain a current inventory of what they have going on with their containers. So I built a geodatabase, set my domains and coded values. I went through and created an attachment for each photo. Just to show an example, here are the containers within the area west of the university. And as you go through, what I found was you're able to create a damage report for each container, whether it was damaged or not damaged. If it was damaged, I would go ahead and take a picture, mark it, and you click on the link, and this is the image you will find of the damaged container. For alleys, what I found was in the same area, I was doing traversability to find out which alley segments had traversability and which ones did not. In this case, there was, I believe, 3 alley segments that were not traversable, and here's an image of one that I took that a collection truck wouldn't be able to go through. For another one that was in study area 2, on traversability, after going through it, this is what I found. If you look at the aerial image, which I first looked at, there's no obstruction here. Going out and doing a field verification, this is what I found in the alleyway. Now this actual alleyway contains containers, but is obstructing the path of the driver. So they have to basically go in, back out, and reroute to go and continue their collection route. This was reported to Environmental Services, where they went ahead and made note of this and are looking into it. And study area 1, I went through and bringing all the data down from the cloud, put it back into ArcMap, and was able to generate some maps based on a surface condition, which had 61 good, 36 average, 4 poor. And I'll just go ahead and speed up because I think I'm out of time, but did the same thing for area 2. Study area 1 did traversability. Same thing with area 2. So for my conclusion, after doing this, you have to have a lot of attention to have a lot of attention to detail for it. You have to have patience. Segment validation is a big thing when it comes to making sure these alleys are out there. I did run a test in Network Analyst with the address ranges, all attribute data structure put in place, and I did have a function where I was able to route from container to container, but I did not provide the results for that. ArcGIS Online, I presented this to my boss, and they're considering redoing the geodatabase, adding new coded values in which we could use that as a way to go out and create damage reports that will link back to the service location where a report automatically be generated to go repair or fix that lid, or if there's an obstruction, get it taken care of. Questions?